Okay, so we are gonna talk about the last two special segments in a triangle, the medians and the altitudes. We're gonna start with our medians. And this goes from a vertex to the midpoint of the opposite side. So if you notice, start at a vertex. How do I know this is the midpoint? Right, that tick mark is telling me this side's equal to that side. So it has to be the midpoint. The three medians of a triangle intersect at a point called the centroid. And what's kind of cool about that is the centroid, if you could like pick one exact spot to balance the triangle like on your finger, that's the centroid. It's the center of gravity, so it's the balancing point of your triangle. So let's go through this diagram and talk about a few things. What are the three medians? If I'm going from a vertex to a midpoint. Kaylee. EF's a good one. What's another one?
EA.
Sorry, what'd you say?
EA.
BA?
EA.
EA, yes, that's another good one. One more. C to what? C to D? What's the centroid? Point P. And then this centroid breaks our median into two different parts. So let's look at this one here. So here's my median AE, right guys? So point P splits it up. From A to P, let's write that. So from your vertex to the centroid, it's 2/3 of the whole thing. So AP is 2/3 of AE. So then that would mean PE is what portion of AE? 1/3. So it breaks up into 2/3 and 1/3. Okay, now let's think about this. How many PEs can fit into AP? Like how many 1/3s are 2/3? Two, right? So we know that AP is double PE, so 2 times PE. Or you could write it the other way. PE is half AP. This is like your generic formula. It will make more sense when you plug in numbers so you can see it, but it's just nice to have that in your notes so you can reference it later on. Okay, let's try a few. So we're given Z as a centroid and then a bunch of different lengths. So let's plug those in and see what we can come up with. So let's do this. So TZ is 60, XZ is 28, and WZ is 25. So if I wanted to find ZV, this guy right here, who has an idea what we should do?
28 times 2.
Right? So I know this is 1/3, so how many of these fit in here? 2 of them. So 28 times 2. What do we get? 56. Perfect. Alright, what's next? ZY. So is this the 1/3 or 2/3 portion? 1/3. So what do I have to do to 60 to get this guy? Divide by 2. 60 divided by 2, 30. ZU. Who has a plan? 25 times 2. 50. TY is the whole thing, so 60 plus 30. Love it. Good work. And same thing for XV. 28 plus 56 is what? How about you start the next and see how far you get before you get stuck? Or help your partner out and then we'll go over it together. Why don't you take a second and compare with your partners around you, and I'll put up the answers on the board. You guys agree with the ones on the board? Did I do them right? Anyone you want to talk about? Or are we all good? We're good? All right. So this time we are asked to find the coordinates of our centroid given a coordinate plane. So let's first plot our triangle and see what happens. So graph those 3 vertices. If you want, you can connect your, make a triangle, but my line's going to be so crooked, I'm just going to wait a second. Okay, now remember your centroid, let's go back. A median goes from what? A vertex to the midpoint of the other side? So we can do that 2 ways. Let's first use the formula, and then we'll use the graph. Does anyone remember the midpoint formula? Anyone? That's slope. Add your x coordinates, divide by 2. Add your y coordinates, divide by 2. So for this one, let's use the formula to find the midpoint of AB, and then we'll go from there. Let's find the midpoint of AB. Hopefully you get 3, 5. Anyone? Want to second that? Perfect. So let's plot that point. So if you wanted, you could use the formula for the other two sides. But since we have a graph, can't we just count? Can we just count since we have a graph? So if you wanted to find the midpoint from B to C, how many up do I have to go? 1, 2, 3, 4, 5. And how many over? 1, 2, 3, 4. Okay, what's half of 5?
0.5.
So I'm going to go up 2.5. 1, 2.5. How many over then?
2.
1, 2. There you go. If that's confusing to you, use the midpoint formula. They'll both work, but you can count mine to make your life easier. Just count. Okay, you find the midpoint of AC any method you want, counting or formula. We'll see if we all get the same thing. Hopefully for AC you got what? 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 5, 7.5. Okay, now connect from your vertices to the appropriate midpoint. So, do we know where they intersect? 5, 5. That is our centroid. All right, and then the last thing we have to talk about so the altitude of a triangle, just think of it as its height. It's the segment from a vertex to a point, so it's perpendicular to that side. So again, your key there is to look for the right angle.
Couldn't that second one just be
Yes. This one right here?
no?
This one?
It couldn't take the inside of it.
No, but you have, yeah, there's 3 different altitudes, so it depends on what vertex you go to.
Oh,
If you want to take a second and draw in the altitudes of these triangles here, it's just demonstrating that it can either fall on the inside, like this one, or if you have an obtuse triangle, it actually is on the outside of your triangle. Or if you have a right triangle, it's either side that make up your right angle could be the altitude of your triangle. But again, your trick there is to look for that right angle to help you distinguish. Your 3 altitudes intersect at the orthocenter. Now let's just label our picture a bit. What are our three altitudes in this picture?
AE,
AE,
DC,
DC, BF. What's the orthocenter? Point D. Okay, take a few moments to see if you can fill in the blanks, because I know we had a lot of terminology the last 2 days, so we're going to try to review a little bit every day so it's not so hard to remember. Take a second, see how you do with filling in the blanks on the bottom. We'll go over them. Help each other, look in your notes, whatever you need to do. Okay, let's see how you did. The three blank blank of the sides of a triangle intersect at the circumcenter. Maybe. Good job. The three blank blank of an angle of a triangle intersect at the incenter. Angle bisector. The three blank of a triangle intersect at the centroid. Medians. The three blank of a triangle intersect at the orthocenter. Good job. A blank is equidistant from the vertices of a triangle. Center. Good job. A blank is equidistant from the sides of a triangle. Center. Good work. Okay, we're going to do a little Kahoot to practice those too. So why don't you take out whatever you need to take out for that, and we'll go from there.